Very good evening to all of you. कैसे हैं आप लोग? How are you all? I know you missed me a lot and even I missed you all a lot. There was a big gap between this, means from the last sprint, from the last time we met and till now. And by this time you would have even passed your class 9th examinations. Right now you must be in class 10th preparing for your boards. Lot of pressure is going to come and lot of things must already be there in your mind, that how we should prepare and how we should plan, how we should study and everything. So let me take the pleasure, let me take this opportunity to describe you everything about the 10th boards exam. In that describing, that due course will go on with the sessions, with the classes. Now what are the classes which I am talking about? So there is something very new and unique which we have planned for all of you. Before telling that, let me introduce myself. Myself, Harsh Priyam, a master teacher of mathematics at Vedantu. I am pretty interested over the CBSE 10th boards, my interest field, and even the Olympiads field. So I am having a very good, great interest over that. So what we have planned, we have basically planned that every day we will be coming to you, not only me, but along with my whole team. Someday physics, someday chemistry, someday mathematics, someday biology, like that. And we will be giving you some most important and some most crucial concepts or the questions according to exams point of view. So that is our thought, and we'll be there on YouTube every day for you guys. And that's a kind of promise. So starting with that, today I am here to tell you a little brief description about those things, and apart from that I'll be even teaching you something. So we will be starting I will be starting with the first chapter of mathematics. In every chapter, I'll be taking some 4 to 5 or 6 or 3, 4, 5, 6, anywhere, means whatever the number of sessions would be required, that much I would be taking. So in all these sessions, I would be giving you the most important concepts and also the most important questions. So the first session with which we'll be starting is going to be real numbers. And I think that by this time you would have even studied real numbers in your schools or coachings or wherever you are going, and you would have learned it. But yes, surely there would be few points where you would have probably missed it, or there could have been some problem in understanding some tough concepts. So I am here to help you out, guys. I don't know how much it helps, but yes, surely I'll be trying my level best. And through your comments, through your chats, I would be coming to know that how much it helped you and how much you got from it. So I'll be constantly be in touch with you guys. Keep on writing, keep on sending the comments, chats, whatsoever, so that I can very well judge that how the content is and what extra do you need from my side. And I'll be doing my level best to give all and everything to all of you. That's my promise. So let's start today's session. So with this agenda, I guess I have made the points clear that what we are going to do this year for all of you and what is there inside the box. And let me tell you, in each and every session there would be something very interesting and outstanding, some kind of surprise or some kind of good things, good questions probably. So there would be every time. So let's start. The first session is going to be about real numbers. Surely this is the first chapter of you all, guys. And by this time, I am very sure that most of you guys might be using the NCERT for your starting reference, means what to study, what not to study, what is the syllabus and all those things. So we will also follow the NCERT pattern so that at least we should do the basic things, and thereafter I'll be even adding up something more above the NCERT level so that even you can do a lot good in your board examinations. So the first chapter which I was talking about is real numbers. In this real numbers, we have learned already types of numbers. In our previous class 9th, we have learned about real numbers, and in this real numbers, there are two parts, rational and irrational. Any number which can be expressed in the form of p by q is rational number. Any number which cannot be expressed in the form of p by q is irrational number, like root 2 and root 3 and pi and so on. Rational number have two parts again. One is integers and another is fraction. So integers and fractions are there. Now again, integers has two parts. One is positive integers and another is negative integers. In this positive integers, we have again two parts. One is whole number and another is natural number. In whole numbers, we have 0 and all the natural numbers. In natural number, we have 1, 2, 3, 4. So this was a brief recap was what you have already studied in your previous classes. So now what we will be studying in this year, in this chapter this time. So there are basically three topics that we need to learn. That is, first says Euclid's division lemma. I guess you all must be knowing it already. In class 9th also you would have learned this. But here we will have some very good examples, very good applications of this lemma. Thereafter there will be Euclid's division algorithm. And thereafter there will be fundamental theorem of arithmetic. Fundamental theorem of arithmetic name is very bulky, but believe me, it's very easy. It's just about HCF and LCM and how to find HCF and LCM. I guess you already know. Just I'll be teaching you some new methods and how we can apply this HCF LCM into multiple problems of daily life also. So this is all what we are going to learn in this chapter, and there will be few more things. I'll be giving you a brief description about that later on. So the first thing which we'll be starting here in today's session is going to be Euclid's division lemma. Now I get multiple questions that, sir, what is the difference between lemma and algorithm? Lemma is a statement which does not require any proof, and algorithm is just the mathematical statement which can be proved, which can be given some what you can say, there can be some points which can suffice that yes, it is completely true. So lemma and algorithm are mostly, in fact this question should not be there. Why? Because it's not at all relevant according to your grades, according to your question requirement of the boards. Board never asks such kind of questions. Anyways, Euclid's division lemma. So what is this Euclid's division lemma? Let's have a look at this. I guess you all must be knowing dividend is equals to divisor into quotient plus remainder. I will just write it, dividend is equals to divisor into quotient plus remainder. I guess you all know this, and we just write it in this form, a equals to bq plus r, isn't it? Dividend is equals to divisor into quotient plus remainder. This is a very basic concept. You all would have learned it in very junior classes, not even in 9th, I guess. So now how to apply this and why we have taken this particular rule in today's session, there is a reason behind it. What is this reason? Just have a look at an example here. Say for example, we have to divide 58 by 9. So I'll be just using this division, 9 here, 58 here, 9 6 is 54 and 4 is the remainder. Now I can write it like this, 58 dividend equals to divisor into quotient plus remainder. Now there is one important rule. Can I, what is that important rule? Before that, can I divide it like this, 9 here, 58 here, and I am doing 9 5s are 45 and then getting the remainder as 13. Is remainder 13 possible? Or if it not possible, can I do it like this? Okay, 13 is again getting cancelled, so I will use it in 1 times, 5, 9 ones are 9, and now I am getting 4 as my remainder. Is it possible? Is it right, this much portion? I guess you all know that this is not right. Why not right? Because the remainder which I got in the very first time should not have been the remainder. This remainder should not have been here. Why? Because if this remainder is anything which is again divisible by 19, it's not correct, it's wrong. Means in the first time this remainder is correct. Why? Because here this remainder is less than the divisor. That is why this remainder cannot be further divided from 9. So this gives us a golden rule that whenever we will be talking about a equals to bq plus r, that is dividend equal to divisor into quotient plus remainder, here one thing has to be always taken care, that remainder should always be less than the divisor. Sorry, not a, divisor, b. Remainder should always be less than divisor. And what is the minimum value which is possible for remainder? Remainder can be 0. So below 0 it cannot be, means we cannot have negative remainders. So it can be equal to 0 or greater than 0, but not less than 0. So 0 is the minimum value, and maximum value is less than divisor. It should not be equal to divisor, otherwise this kind of mishap will happen. If we will have a number which is again divisible by 9 or any divisor, we'll again divide it and we'll get a completely wrong quotient, isn't it? Because 51 into 9 is something very different, not even equal to or any near about even 58. So I guess I made my point clear that dividend equals to divisor into quotient plus remainder, where remainder should be always less than the divisor and it should be greater than 0. So this is the condition, and on this condition we are going to dedicate our whole class. There are multiple type of questions that needs to be answered using this concept only, and which is very relevant according to your grades and according to your board examinations. So let's see them, have a look at it. So this is very important. Please take a note of this. I've even written all the points and concepts which we are teaching in today's session. So you can take a snapshot if you wish to. Now let's see how we are going to apply this. So first of all, we will get these kind of questions in examinations also. So let me tell you that these questions are very important from exam point of view. I know that you will understand it very easily, but from exam point of view, these questions are very important. And in exam, steps are very important thing. You need to know that which steps you need to write and where you have to put which step, because this fetches you marks. So always remember that when I'm teaching you this, please watch out the steps. It's very important. So first of all, we have to prove that the one of every three consecutive integers is divisible by 3. So whenever any such question comes where you have to check the divisibility or you have to show something or anything like this, then whatever the number is being given here, just take this number as your divisor. As your divisor. What did I say? I said divisor. Divisor, if you remember, we have taken a equals to bq plus r. In this number we have taken divisor as b, so that's why I just wrote down b. This is divisor, so I can write this number a is equals to 3q plus r. Is it possible now? Okay, now if this is possible, I have just now said you one concept, that remainder will be always less than the divisor and greater than or equal to 0. So we have a condition. So remainder will be either equal to 0 or greater than 0 but less than 3. So what are all integral values possible for this remainder? So 0 can be possible, r can be equal to 0, or r can be equal to 1, or r can be equal to 2. There is no other options possible. And even if you will try to understand it from other side, you will be able to understand that if I divide any number from 3, the remainder is only possible 0, or it can be 1, or it can be 2. Remainder can never be 3, because if I am getting a 3 remainder, then again it will be divisible, and that's wrong. So we have 3 remainders, 0, 1 and 2. So now we will draw, we will make cases. I'm just writing case 1. So if I'm writing case 1, in this case 1, a can be written as 3q plus 1, 3q plus 0 for remainder equal to 0. Remainder equal to 0. Again, case 2 I am writing here. So this is case 2. This case 2 is a equals to 3q plus 1. And in this case 3, I will write a is equals to 3q plus 2. So these are my 3 types of number which is possible for r. Now, this is this much conclusion I have drawn only from the last line, this last part, not last line, last part. Now what we have to prove, now let's concentrate on the question. Prove that one of every 3 consecutive positive integers. Consecutive means we will be taking 3 numbers which are consecutive, one after another. So I have assumed that number to be a. That is why I have shown this number, this positive integer in this form, a equal to bq plus r. So I have taken this number as a. So if I need to write 3 consecutive integers, I will take the numbers as a plus 1 and a plus 2. So I'll just write a line here, let the numbers be. Let the numbers be. Now this line should have come here, but I did not write this line in the very starting. Why? Because I wanted you guys to understand that how we are going to apply the concept which we have just now learned. So please pay attention. While you will be writing it in the exam, this will be your first step, this much. And then this whole second step will means after this whole thing will come. Okay. So if I am clear, I'll just write it down in the next page. So I have taken 3 numbers, a plus 1 and then a plus 2. So I'll just make 3 columns, a plus 1 and then a plus 2 like this. So you can make like this only in your examination also. Now I'm writing here cases. Case 1. So in case 1, if you remember that a was equals to 3q. If you remember here, see here, case 1, a was equals to 3q. 3q plus 0 means 3q. So if a is equals to 3q, I'm writing down here, then value of a is 3q. And if I write it down, value of a plus 1. So if a is 3 cube, a plus 1 will be 3 cube plus 1. And similarly, a plus 2 will be 3 cube plus 2, isn't it? Now, if I write case 2, for case 2 you must be remembering that a was equals to 3 cube plus 1. If you remember here, see here, for case 2 a was equals to 3 cube plus 1. So we'll just write here, in place of a it is 3 cube plus 1. Now if I put the value of 3 cube plus 1 here, it will be 3 cube plus 1 and plus 1. So I'm just writing it down 3 cube plus 2, because 1 plus 1 will be 2. And if I put the value of this 3 cube plus 1, value of a here, so 3 cube plus 1 plus 2, so it will be 3 cube plus 3. Okay, that's fine. And this is the third case which we were talking about, means which we had a is equals to 3 cube plus 2. If you don't remember, just have a look here, a equals to 3 cube plus 2. So we have this third case. So 3 cube plus 2, then a will be having a value 3 cube plus 2. And I can put this value here also. So in this case, it will be 3 cube plus 2 plus 1. So this is 3 cube plus 3. And here 3 cube plus 2 plus 2. If I put the value of a 3 cube plus 2 here, it will be 3 cube plus 2 plus 2. So it will be 3 cube plus 4. That's fine. Now, so we have totally 9 numbers, 3 and 3. 3 threes are 9. Out of these 9 numbers, we have to, what we have to prove, just see here. Prove that only one of every 3 consecutive positive integers is divisible by 3. Only one of every 3 consecutive integers. So these are the 3 consecutive integers, first, second, and this is third. So in these 3 consecutive integers, only one will be divisible by 3. So out of these 3 cases, I guess only this is the first case. Let me change the color. I'll just show you. It will be more visible. In the first case, this is divisible. Out of this second, out of these all 3 cases, only this is divisible by 3. Why? Because here 3 will be taken common. Here also it is divisible. Why? Because 3 is common here. And in this third consecutive number, out of these 3 cases, only this number is divisible. So I will write here that these 3 cases are divisible by 3. I am writing here divisible by 3. So out of these 3 cases, out of these 9 cases, only these 3 cases are divisible by 3, and therefore I'll write, hence out of 3 consecutive integers, only one is divisible by 3 at a time. So if I even look out of these 3 cases, only one, 3 cube. In the second case, out of these 3 cases, only one. And in the third case, out of these 3 cases, only one is divisible by 3. So whatever is written here, that whatever you have to prove, just write down. Therefore, only one of every 3 consecutive positive integers is divisible by 3. So I am just write here, therefore only one out of 3 consecutive integers is divisible by 3. So this will be our final concluding statement. So this is how the questions are being asked in the examination, and this is how you have to answer them. And this is very important. Let me tell you, this is very important. It might be looking very easy and very obvious that, sir, it is very obvious if out of 3 integers, surely only one number is going to be divisible. We can take multiple examples. But let me remind you, in examination, in board examination, we cannot prove any question using examples. We will have to write the steps, and that to the correct step which is accepted by the board. So this step will be surely accepted, and if you have understood this, this is really awesome. Fine. So let's this is the whole solution. Also I have done it for you guys, kind of bookish solution. If you wish, you can even take a snapshot of this. You can understand it from here, or you can, if you wish, you can write it like this also, and you can write it like this also, whatever you wish to. So there are 2 solutions which I have given you, so you can go with this. Now if you have understood this, I would like to show you one more question. Do you guys wish to see one more question? Are you ready? Just tell me. Okay, so that's fine. Let's see one more question. Now here we have one more question, that prove that square of any number is always of the form 4m or 4m plus 1. Square of any number. So what does this any number means? So let's have attention. See, if I wish to bifurcate these any numbers, I can bifurcate minimum them in 2 types. First, even number, and second, I can write at odd number. because there are only two types of numbers possible. Now you can say me surely that sir there are multiple types of number. So let me say you that prove that square of any positive or any positive integer will be written here. It will not be written here any number. In the examination it will be written here any integer, positive integer basically. So any positive integer. So this question is only proved for any integers only. So integer can be of two types, even or odd. Now do you know that even numbers can be written in the form 2k? Because if I multiply any number by 2, it will be surely an even number. Whatever value k holds, that is hardly a matter. If there is a 2, surely it is going to be an even number. So if 2k is even, because it's divisible by 2, if 2k is even, I can simply write 2k plus 1 as odd, because just next number, if I just simply add 1 in an even number, it will be an odd number, isn't it? So this 2k plus 1 is an odd number. So we have got our two types of number. So I will just say let the number be x. I'll just say here let the number be x. Let the number be x. So I can say that case 1, in this case 1, x can be an even number. That can be 2k. So now the question is saying that prove that the square of any number, we need square. So I'll just do square here. It will be x square and that will be 2k whole square. So that 2k whole square makes it 4k square. And now if I assume this k square as any number, then it is a multiple of 4. Are you able to see that 4 is since multiplied here? So this is basically a multiple of 4. So can I write it like 4m? Multiple of 4. Multiple of 4 means 4 is multiplied from in that number and there is any other number also written there. So this is also is of the form 4m. Now take a case 2 here. In this case 2, I can write x can be odd also. So if x is odd, I can write it like 2k plus 1, isn't it? If this is an odd number, then let's do the square of this. So I'll write here 2k plus 1 whole square. Now you all know a plus b whole square. Let's write it down here. So this is x square is equals to 4k square plus 4k plus 1, isn't it? Now in these two numbers, I am able to see 4 as common. So I'll write here k square plus k plus 1. Now again, this number is a multiple of 4 because 4 is multiplied here. So I can write this as 4m multiple of 4, and plus 1 is also here additional. See, many of the students might be having that, sir, you have just now assumed m equals to k square here. So see, it's not an assumption that I have given a value k square to m. It's just like that it's a multiple of 4. So I am writing it in the form of 4m. Why? Because we have to prove it in this form, 4m. So here I can assume, if you are not feeling comfortable, you can just simply write a note here that m is equals to, we have assumed m equal to k square plus k here. And you can assume two different values for m. So this is 4m plus 1. And this was being asked from us that we have to prove that square of any number. These are the only two possible numbers, even or odd. When I did the square, I am getting either 4m or I am getting either 4m plus 1. Therefore, I'll write hence proved that square of any number is always of the form 4m or 4m plus 1. And this is how different type of questions would be asked. Even there might be one question that prove that all odd integers are always of the form 4q plus 1 and 4q plus 3, or it can be 6q plus 1 or 6q plus 3 plus 6q plus 5. There could be multiple type of questions over this theory, but let me tell you, this is very important from the examination point of view. So just try solving multiple type of questions so that you should not miss any different type of questions which you will directly see in the examination. Keep on practicing as much as you can. If you feel any problem, do reach out to me. You can put it down in the comments box and I'll be responding to that. So this was all from my side. Myself, Harsh Priyam, signing off at this junction with a promise that I'll be seeing you again in next session, and we'll be having multiple sessions and multiple discussions to make maths more interesting. See you guys in the next session. Till then, bye-bye and take care. Bye.